Hello, Physics Nation. My name is Nate Larmond, and let's talk about work and energy. We're going to do a simple experiment. You're actually going to lift yourself up a number of times on a chair at different rates. So you are going to do this experiment right here. We're going to see how your power output affects your heart rate. And you're going to change your power output and your heart rate by doing this exercise in different periods of time. So it says human power output and heart rate as a function of time to do 20 chair step-ups. Again, this is how the math teachers like to organize functional language. They say y as a function of x, except in this experiment, we have two y's, two dependent variables. We're going to see how power is affected by time, that is the rate that you do this exercise, and how your body, how your heart rate reacts to the time it takes you to do this exercise. All right, so you can climb a set of stairs, that's cool, or you can lift yourself up in a chair. This is how I traditionally do the experiment. Either way, it's a pretty simple experiment. Basically, you need your weight in newtons. So 1 pound is 4.45 newtons. Just take your weight in pounds, multiply by 4.45, or take your mass in kilos and multiply by 9.8, or roughly 10 newtons. When you lift yourself, you're doing work. That is, you're applying a force through a distance. I am pushing on the measuring cup. I am doing positive work because my push is in this direction and the motion is in this direction. However, friction is doing negative work. Friction opposes this motion. And so if the force is in the opposite direction to the motion, you do negative work. Friction is stealing energy from the system. I am dumping energy into the system. So my finger is doing positive work, but friction is doing negative work. Anyway, when you lift yourself onto the chair, you are doing positive work because the force is upwards and the motion is upwards, except it isn't lost as heat, as thermal energy. That's called a non-conservative force. Friction is a non-conservative force. You actually gain gravitational potential energy. That's a conservative force. You can get that energy back. Okay, so force times distance is work. Take your newtons multiplied by the height of the chair in meters. That's the work it takes to lift yourself once, except you're going to lift yourself 20 times. So take the work it takes to lift yourself once, multiply by 20. That's the work you're going to do when you lift yourself 20 times. Then measure your resting heart rate just to get a baseline, and then time how long it takes you to lift yourself 20 times. Divide the total work, that is the work for 20 lifts, by the elapsed time, and that's called your power output, your wattage. Joules per second is watts. As soon as you finish your exercise, take your heart rate. I like to do this. Some people like to do this. Find how many beats per minute your heart is going. Okay? You can count the beats in 10 seconds and then multiply by 6 to get the beats per minute. Rest to get back to your resting heart rate, and then change the pace that you do the exercise. That is, do a slow set, measure your heart rate, time how long it takes you to do 20 reps, come back down to resting. Do a medium set, time how long it takes to lift yourself 20 times, measure your heart rate, come on back down to resting heart rate, and then lift yourself really fast. Okay, so you're varying the time to see how power output and your heart rate respond. I'll see you back in the comments. Thank you much.